Once upon a time, in a bustling little town, there was a baker named Leo. Leo owned the Crumb and Crust, a bakery famous for its chaotic, wonderful smells. Leo was a fantastic baker, but a terrible guesser. Some days he baked hundreds of chocolate chip cookies, only for everyone to ask for blueberry muffins. Other days, he baked mountains of muffins, and everyone wanted cookies. He was losing money and losing sleep. One afternoon, a regular customer named Sarah sat at a corner table. Sarah was a statistician, a kind of data detective. Seeing Leo look exhausted, she offered to help. "Leo," she said gently, "you don't need to guess anymore. You just need a little statistics." "Statistics?" Leo groaned. "I'm a baker, not a mathematician. Numbers give me a headache." "Don't think of it as math," Sarah smiled. "Think of statistics like tasting a pot of soup. When you make a giant vat of tomato soup, you don't drink the whole pot to know if it needs more salt, do you? You stir it, take one spoonful, taste it, and you instantly know about the whole pot. That is exactly what statistics is, taking a small amount of information and using it to understand the bigger picture. In this video, we'll learn what statistics is, its main types, where it's used, where it shouldn't be used, the different types of data, and the essential concepts every beginner must know. Let's get started. What is statistics? At its simplest, statistics is the science of collecting, organizing, analyzing, interpreting, and presenting data to draw meaningful conclusions. Every day, statistics helps governments make policies, businesses predict customer behavior, doctors test medicines, and even weather experts forecast tomorrow's weather. Without statistics, we'd just have a pile of numbers with no clear meaning. The two main types of statistics. Statistics is divided into two major branches: descriptive statistics and inferential statistics. First, let's talk about descriptive statistics. Descriptive statistics is used to summarize and organize the data you already have. It doesn't make predictions or guesses. It simply describes the information in front of you. To do this, descriptive statistics uses averages, percentages, tables, charts, graphs. Imagine a teacher checks the results of a math test. She finds class, average, 78%, highest score, 96%, lowest score, 54%. These numbers describe only that particular class. No predictions are being made. That's descriptive statistics. Now let's talk about inferential statistics. Inferential statistics goes one step further. Instead of studying everyone, it studies a small sample and uses it to make conclusions about a much larger population. It uses tools like hypothesis testing, confidence intervals, probability models. Example: suppose researchers test a new vaccine on 2,000 volunteers. Using those results, they decide whether the vaccine is safe and effective for millions of people. That's inferential statistics. It uses a sample to make informed conclusions about the population. Where is statistics used? Statistics is everywhere. Let's look at some real-world examples. Medicine and healthcare. Before a new medicine reaches hospitals, scientists conduct clinical trials. Statistics helps determine whether the drug actually works better than a placebo and whether it's safe. Business and e-commerce companies use statistics to predict future demand, so products don't run out of stock. Recommendation systems on streaming and shopping platforms also rely heavily on statistical models. Weather forecasting. When you hear there's a 70% chance of rain tomorrow, that's statistics at work. Meteorologists combine historical weather patterns with current atmospheric data to make predictions. Quality control. Imagine a smartphone factory producing 10,000 phones. Instead of testing every single phone, inspectors might examine 50 randomly selected phones. If those phones meet quality standards, they can estimate the quality of the entire production batch. Where statistics can't be used. Although statistics is incredibly powerful, it has important limitations. Biased samples. If you survey 500 customers at a luxury sports car dealership about average income, the results won't represent the general population. A biased sample leads to biased conclusions. Sample size is too small. Suppose you flip a coin only 3 times, and it lands on heads every time. That doesn't mean the coin always lands on heads. Small samples can easily produce misleading results. Moral or ethical questions. Statistics can tell us how many people support a law, but it cannot tell us whether that law is morally right or wrong. Numbers describe opinions. They don't determine ethics. Absolute certainty. Statistics never guarantees outcomes. It deals with probabilities, not certainty. It tells us what is likely to happen, not what must happen. Types of data in statistics. Before analyzing data, we first need to understand what kind of data we're working with. Data is divided into 2 main categories: qualitative data and quantitative data. First, let's talk about qualitative data, also known as categorical data. Qualitative data describes qualities, labels, or categories rather than measurable numbers. There are 2 types. Nominal data. Nominal data consists of categories that have no natural order. Examples include eye color, blood group, gender, yes or no, responses. There's no ranking among these categories. Ordinal data. Ordinal data has a meaningful order or ranking. However, the difference between categories cannot be measured precisely. Examples include movie ratings from 1 to 5 stars, small, medium, and large, t-shirt sizes, first, second, and third place in a competition. These categories are ordered, but the gaps between them aren't equal or measurable. Now let's talk about quantitative data, also known as numerical data. Quantitative data consists of measurable numbers where mathematical operations make sense. It has 2 types. Discrete data. Discrete data is countable. It consists of whole numbers only. Examples include number of students in a classroom, number of cars in a parking lot, number of goals scored in a football match. You cannot have 25.4 students. Only whole numbers are possible. Continuous data. Continuous data is measured along a scale. It can take any decimal value. Examples include height, 172.45 centimeters, race time, 9.58 seconds, temperature, 23.8 degrees Celsius. Unlike discrete data, continuous data can have infinitely precise values. Essential beginner concepts. Now let's learn some important concepts that appear throughout statistics. Population versus sample. A population is the entire group you want to study. For example, all 8 billion people on Earth. A sample is a smaller portion selected from that population. For example, 10,000 randomly selected people. We usually study samples because studying the entire population is often impossible or too expensive. Parameter versus statistic. A parameter describes the entire population. A statistic describes only the sample. Here's a simple memory trick. Population goes with parameter. Sample goes with statistic. Both start with the same letter. Measures of central tendency. When people ask, "What is typical?" statisticians usually use three measures. Mean. The mean is the average. To calculate it, add all the values together and divide by the total number of values. Example: suppose 5 students scored. Add them together. Now divide by the number of students, which is 5. So the mean score is 80. Median. The median is the middle value after arranging the data from smallest to largest. Example: consider these numbers. They are already in order. The middle number is 70, so the median is 70. Now consider an even number of values. There are two middle numbers, 60 and 70. So we take their average. Therefore, the median is 65. Mode. The mode is the value that appears most frequently in the dataset. Example: suppose the data is. Here, 8 appears twice, while every other number appears only once. So, the mode is 8. Another example. Here, both 2 and 4 appear twice. This dataset has two modes, so it is called bimodal. Variability or spread. Knowing the average alone isn't enough. We also need to know how spread out the data is. Range. The range is the difference between the highest and lowest values. Example: suppose 5 students scored. The highest score is 80 and the lowest score is 60. Range equals 80 minus 60 equals 20. So the range is 20. Variance. Variance measures how much the data values differ from the average. A small variance means the values are close to the mean. A large variance means the values are spread farther away from the mean. Example: consider these two datasets. Dataset A. Dataset B. Both datasets have the same mean of 70. However, the values in dataset A are very close to 70, while the values in dataset B are spread much farther apart. Therefore, dataset A has a low variance, and dataset B has a high variance. Standard deviation. Standard deviation tells us how far the data points typically lie from the average. It is simply the square root of the variance, making it easier to understand because it is expressed in the same units as the original data. Correlation versus causation. This is one of the most important rules in statistics. Just because two things happen together doesn't mean one causes the other. For example, ice cream sales and shark attacks both increase during the summer. Does eating ice cream cause shark attacks? Of course not. Both happen more often because of a third factor: warm summer weather. This is called correlation, not causation. Always remember this distinction whenever you interpret statistical results. Statistics is much more than numbers. It's a powerful tool for understanding data, making predictions, solving real-world problems, and making informed decisions. Today, we learned what statistics is, the difference between descriptive and inferential statistics, where statistics is used, its limitations, the different types of data, population and sample, parameter and statistic, mean, median, and mode, variability, and the crucial difference between correlation and causation. Master these fundamentals, and you'll have a strong foundation for learning more advanced topics in statistics. If you enjoyed this lesson, don't forget to like the video, subscribe to the channel, and share it with someone who wants to learn statistics from the beginning.